Hey everyone, welcome to the first ever Practical Engineering live stream. I'm here in my garage, as Ty Lopez would say. It's a little chilly today here in San Antonio, as that Arctic blast from the north is just starting to find us down here in Texas. So I've got my my vest and my coffee, and I'm ready to chat. A live stream is something a lot of people have been asking for, and something that I've been wanting to try for a long time. So I'm a little nervous about how it's going to go, but excited to finally give it a shot. If you're familiar with the channel, you know that most of the videos that I make feature some kind of homemade demonstration of some kind that I build here in the shop. And one of the most prevalent comments I get is, "Hey, you built this cool demo, but we didn't get to see very much of it in the video. We want to see more of the demo." And so for the people who want to see more of the demos, hear a little bit about how they work, or just hang out with me for an hour, this is for you. It's totally an experiment. So didn't put a ton of planning or preparation into this, just kind of winging it. And I do want to hear a little bit about what you think about the idea of live streaming, and if you have suggestions for changes in format or changes in time. I know not everyone can join a live stream in the middle of the day, but yeah, any feedback you have, please email it to me. And so yeah, if people like it, we'll turn it into a regular thing. And rather than listen to me ramble on the whole time, I have a little bit of an agenda. So let me pull that up here. Still learning how to run this thing. There we go. So yeah, first things first, we'll talk a little bit about the wave generator from the past video about coastal erosion. Then we'll take some questions from the chat and see if we can answer some of those. And then I actually have some preloaded questions submitted from patrons over on Patreon. So so we'll answer some of those questions, and then if there's any more time within the hour, we'll take some more questions from the chat. So with that, let me see if we can get our cameras fixed up here, and we'll switch over to the wave generator, which is right over here to my left, your right. There we go. And actually, I'll take it full screen. Everyone can hear me okay, right? I'm mic'd up with a wireless mic, so. Alrighty, well, this is the wave generator that I built for the demo. You might this acrylic flume. It's been featured in a lot of my videos. It's something I built at first just to demonstrate one feature of fluid dynamics, and that's the hydraulic jump. And it's just turned out to be so useful in so many other videos that I've kind of tried to keep using it. Over here to the left, you see just a regular benchtop power supply, and that's sending power to this control board, and then also to the servo that controls the wave generator. So I'm going to power this up, and I'm sure there's a way to make this servo return to the same place every time, but I haven't figured that out. So what I do is just tighten these set screws each time. So give me just a sec to tighten those up. So yeah, what's powering the servo is an Arduino microcontroller board. If you've been with me for a long time, you might recognize this box. This was built way before the channel was called Practical Engineering, and it was just kind of a puzzle, just a fun way to combine woodworking and electronics and learn a little bit about programming microcontrollers. So it wasn't really purpose built for this, but it has these nice potentiometers here already, so I decided to go ahead and reuse it. So inside the box, there's a big mess of wires, but really the only thing I'm using is the Arduino here, and then the 3 potentiometers. These panel indicators aren't doing anything for this project. And the way this works is, at least for my case, all I did was program a sine wave into the Arduino, and these potentiometers control different aspects of the sine wave. So the middle one controls the amplitude of the sine wave. So I have it turned all the way down now, so it's not moving. But you can see the higher we turn it up, the bigger the amplitude of the sine wave that controls the servo. And then this controls the period of the sine wave. So right now it's on really slow, and I can turn it up and speed it up. And then this third one kind of makes the sine wave asymmetric, so that you have a stronger or a quicker forward stroke than backstroke. So you can kind of see it's fast on the upstroke and slow on the downstroke. So I don't know how useful that was. You know, there's a lot of science to these wave tanks, and I'm just a beginner. You know, there's a lot of really cool wave tanks all across the world in research labs at universities, and there's a lot to this that I haven't gone into or know anything about. So definitely, if you have experience with wave tanks or how they generate waves and the science that goes into that, let us know in the chat. We'd love to hear about it. I hope that's not too loud. This servo is quite loud, but I'm on a lavalier mic, so hopefully it's not being picked up too bad. The servo itself is geared down with these aluminum gears, and then I have a shaft running from either side of the flume that's attached with a set screw to this hub, and then yeah, it just has a big aluminum plate bolted to the shaft, and that gets moved with the servo. And these are all parts made by a company called Servo City, I believe. They kind of build these aluminum, almost Lego parts called Actobotics. And I really like it because, you know, I don't have a mill and a lathe in the shop. It's hard for me to fabricate stuff like this. So even though it's kind of expensive to buy these things, it really is convenient to cobble together little mechanical things like this. So it was really helpful for this project, and you've probably seen these in a few of my past videos. So now I'm going to take a step back here with this camera. Let's see how that looks. You'll have to forgive my live production skills. And let's get this thing. Oh yeah, we got to get Bodie McBoatface in here for the comedic relief and as a mass simulator. There's some nice sized waves going. So yeah, that's it. You know, the purpose of this demo, and we'll talk a little bit more about this later, but it's not necessarily to model an exact condition within the real world, right? Waves rarely hit the coast perfectly perpendicular like you're seeing in the model. You know, the purpose more is, number one, to make something that looks nice on film and helps illustrate the concept of erosion. But number two, it's just to show that, hey, even small waves have a big impact on sediment. And you can see very clearly in the model that even these tiny waves are able to move sediment and change the shape of this model beach that I have. So that was kind of the purpose of the demo, and I hope that came across well in the video. So I'm going to let this run, and I'm going to jump on the chat and see if there's any good questions on here. Holy smokes. We got a lot of questions here. Power consumption. That's a good question and an easy one to answer. I don't know how well this will show up on camera, but you know, the power supply has a reading of the current, so it looks like it's jumping between about 0.2 and half an amp. at 7 volts, so not a lot of power. Someone can do that math for me. I don't have a calculator pulled up. Let's see. How long did it take the demo? How long did it take to build the demo? That's a great question. I mentioned this acrylic flume is something I built quite a while back for another video. And so this demo really was just all about the electronics. You know, these Actobotic parts are really nice to use. You know what I should do? There we go. Now you can see my face. These Actobotic parts are super easy to use and put together. So, you know, there's not a lot of fabrication involved, but most of the time is just kind of planning and designing and seeing what parts are available that you can cobble together to do what you want it to do. So, I don't know, probably a few hours on the computer planning and thinking it through, and then a few hours out here in the shop putting it all together. Oh, and maybe a few hours on the computer coding the Arduino as well. Does the wave? Oh, here's a good question. Does the wave on long runs get resonated? So yes, it does. And I played with it quite a bit. I can adjust the dials. Actually, here's an idea. Let me just put a little wall in here, and you can really see how the waves, they are being reflected, but if you put something like this in, you can see even if you stop the wave tank, you're getting a lot of reflections back and forth of the waves. So it's definitely an issue. You know, like I mentioned, this I'm not doing any real science here in the garage. This is purely, you know, a fun thing to show on camera, and it does a good job demonstrating what I wanted to talk about in the video. But if you were researching waves or researching coastal erosion, you'd probably want a better tool than this one. How long is it? Good question. Let's just find out, because I don't recall off the top of my head. For anyone who's building one at home, it's 6 feet, so just a little under 2 meters, and 6 inches wide. So 15 centimeters. Oh. Are you planning a different rig to demo longshore drift? So this is a question that I'm going to talk about here in a minute from Patreon. Right now, the answer though is no. That's a pretty challenging phenomenon to model here in the garage. So right now I'm not planning that, but if I think of a cool way to do it, then I definitely will. How expensive is the demo? Off the top of my head, I really don't know. Those Actobotic parts are a little bit expensive, but again, for me, it's worth it because it saves a lot of time in the fabrication. And you could go on Servo City and take a look at all the parts they have. You know, it's not completely out of the realm of a hobbyist or whatever, but they are a little pricey compared to, you know, if you had a machine shop and you could fabricate everything yourself. There's so many comments coming in. There we go. This question is, where do you get the clear plastic material? For the most part, from a website called Tap Plastics. They offer, you know, some pretty reasonable prices on clear acrylic, and they also just do a lot to support, you know, the home hobbyists like me who are, you know, who don't have all the tools and expertise to to fabricate things out of acrylic. It really is a special skill, and there's a lot to it. So so yeah, I use tap plastic for most everything. This question is, does the salinity of the water influence the erosion rate? That's a great question. And I think the answer, you know, I'm not a coastal engineer, so this is not something that I have a ton of expertise in. The one difference that I can speak on, though, is just the difference in density between freshwater and saltwater. You know, with saltwater being a little bit more dense, those waves have a little bit more power to create erosion over time. Let's see where we are on time here. Oh yeah, we've got time for more questions. Jersey says, do civil engineers today make models to test designs of their constructions? And the answer to that is yes, they do. There's a few different fields of civil engineering where, you know, the computer models can only do so much. One of them actually is hydraulics, right? For spillways and pump stations and anywhere where you have complex hydraulic phenomena, you can only do so much with a computer model. And so, yeah, we still do build scale physical models to characterize hydraulic phenomena. Another one is wind, especially for like tall skyscrapers. A lot of times that you'll build a wind model because, you know, the flow of wind around all the other buildings and all that is really complicated to characterize on a computer. And so a lot of times to estimate wind loading on a skyscraper, they'll build models. Here's a question. Would you be able to test offshore breakwaters, gabions, etc. with this model? How accurate would it be? So I mentioned before, you know, the limited length of this thing means there's lots of reflecting waves. So that is a real challenge of modeling this type of thing. So that, I think that would give it a lot of problems. Obviously, you know, for certain things, this can handle just fine. But if you're really trying to validate a design, you probably would want something a little more sophisticated than what I'm showing here. This question from Chris says, did you consider a vertical displacement motion as well as the swinging vane for wave generation? Yeah, I did. And really, this was just me looking through the catalog of Actobotics and seeing what I thought I could feasibly put together with some confidence that it would look well on screen and you know, do what I wanted it to do. So there are a lot of really cool ways of making waves, both at scale and full scale. Like, you know, there's that train that pulls a sled that generates a wave for surfing, and there's wave pools all across the US, you know, for recreation that have really creative ways of generating big waves. So there's a lot of cool ways to do this. All of them are very energy intensive. Obviously, water is heavy and it's hard to move around like this. But yeah, there's a lot of cool ways to do it. And this is just the one I settled on because it was easy for me to put together. Let's see. Someone said, any advantage of using a servo plus programming over a purely mechanical design? Yeah, it's just what I know. I have some experience programming an Arduino, so anytime I have to do something that's going to involve motion control or something like that, that's just my default thing that I go toward. To me, I think better in code than I do, you know, linkages and levers and gears and stuff like that. And so if I can get it into a software format, then it's just easier for me to conceptualize that. I think now, someone asked, what's your favorite bridge? And that's a great question. There's a cool bridge in Austin. I'm in San Antonio, but I used to live in Austin, and there's a really neat bridge made out of Corten steel in West Austin called the Pennybacker Bridge. It's not one of the mega bridges in the world or anything, but it's always just held a really special place in my mind because it was something that I saw regularly, and I think it's a really nice design. With that, I think I'm going to go. I think I'm going to go to the Patreon questions now. So give me just a minute to switch gears here. And actually, let me pull that wave wall so we can see some erosion happening on the screen. Let's get Bodie McBoatface jumping around a little bit here. There we go. So this question came in through Patreon, and it says, your model shows what happens when waves approach the perpendicular to the coastline. Can you talk about the differences we might see with longshore drift scenario? And this is great feedback. There were quite a few people who made similar comments to this. Obviously, the video I made was talking about coastal erosion, which is where parts of the shore are lost to sea. But a more general video may have covered all of coastal sediment transport, right? Including deposition of sediments and longshore drift, which is when the sediments are moved along the coastline. As I mentioned, coasts are very geologically dynamic places, and erosion is just part of that picture. Waves can move sediment from the seabed onto the shore, depending on the size of the sediment and the characteristics of the waves. And they can also wash sediment along the shoreline. So this is one of the most prevalent processes, sediment transport processes, because you almost always have waves hitting the shore at an angle. And so that sediment moves along the shoreline rather than straight up or straight down, basically. You also have rivers carrying sediment from upland areas out to sea. And I know there's another question about that in a minute, so I won't go into that. But a big part of coastal engineering or ocean engineering is understanding sediment transport mechanisms. A lot of coastal projects are simply dealing with erosion or dealing with the movement of sediment. So it would be really cool to build a model that could show these other sediment transport processes. And I'm going to be thinking about ways to do that. I don't know if my garage is big enough for some of those. But yeah, erosion was the focus of the video I made, but that definitely isn't the totality of coastal sediment transport. Let's see here. Another question from Patreon is, what models are used to understand coast dynamics? Could we quantify a flow of sand precisely over time? And that's a great question too. The answer is yes, depending on your definition of precisely. There are lots of coastal models out there that can do different things. Again, this is not something I'm an expert in, but there's several numerical models that have been developed over the years to characterize coastal processes, a few of which I know a little bit about. But it really depends on what question you're trying to answer. So, for example, if you're just looking at a one-dimensional or a two-dimensional cross-section of the coast and wanting to understand how that's going to change over time, there's a model for that called Seashore. And I actually have some pictures of these, if I can pull them up. So this is kind of similar to what my model shows, like a small cross section of the shore and how that might change over time due to wave action. There's also models that look at waves. So offshore waves are fairly homogeneous, but once you get near to the shore, there's lots of factors that affect the height and period and direction of the waves. So there's a model called ST-Wave that helps characterize and understand those factors that can have a big impact on the design of coastal systems. So that's a picture of ST-Wave. And I believe all three of these that I'm mentioning were developed by the U.S. Army Corps of Engineers. And so, you know, the other question was about, you know, can we characterize the flow of sediment accurately? So there's a model called CMS, the Coastal Modeling System, and this can do really a lot of stuff. It can do 2D flow. It can do waves, characterize waves. It can model sediment transport processes, and it can also model bed change, right? How the morphology of the bed of the ocean and the beach changes over time. So there are definitely ways that we have to model these processes. It just depends on what question you're trying to answer, and obviously depends a lot on how accurately you need the question answered. Let me move on to the next question here. Oh, we got a few questions from the chat that I can address real quick. How did you consider the harmonics and set the wave period? I can imagine it'd be easy to accidentally have a destructive interference issue. Yeah, definitely so, and that's why I coded the Arduino to be adjustable, so that, you know, if I did have a period where you were destructively interfering with the reflections, I could just change the period a little bit and make an adjustment there. So I didn't really choose. I just kind of fiddled with the knobs until I got something that looked like what I wanted. Another question was, do mangroves stop erosion by holding back soil washing out to sea, and not only by reducing waves hitting the shore? And the answer to that is yes. So not only do mangrove forests break up the energy, it cause turbulence and break up that wave energy, but also all those roots and vegetation hold the soil in one place. So it's almost like the soil is anchored to the ground, and so it would take even more shear stress to dislodge those particles and carry them away. One question is, how could you increase the energy in the model to greater simulate natural disasters? This is from a classroom, Mr. Farr. So I'm Mr. Farr and all your students. Great question. We can play with it a little bit and see, but you know, I'm kind of limited by the strength of the servo and me wanting to avoid getting things wet. But let's go play with it and see what happens. Let me turn off this other question. So a natural disaster might be like a hurricane, where you have very, very strong straight line winds that generate very high waves. So we can just try to make some big waves and see what happens. You know, so when I chose the gear ratio for the servo, I tried to pick, you know, something that would have enough torque to move the water, but also have enough speed, you know, to do what I wanted it to. I probably could have chose something a little bit more, a little bit less geared down, because as you can see, I'm limited by the speed of the. If I turn the speed up, I just get smaller and smaller displacement of the waves. So, unfortunately, I can't simulate anything too crazy in this model. But a way to do that might be to change the gear ratio here, so the servo can swing a lot faster, and that might require a bigger servo that has more torque, because moving water around like that takes a lot of energy. Great question. Let's go to another one of the Patreon questions. This one from Lima Victor says, beach nourishment is the way that Netherlands keeps its coastline mostly constant. The interesting bit is that there are pretty much just one or two spots where it happens. And I had to cut off the rest of the comment, but what the project he's referring to, and I'm sure I'm going to pronounce this wrong, is called the Zon motor, which translates into English as sand engine. And this is a really, really cool project. I only know the high-level details of it. There's a lot of complexity here, obviously, but the Zonmotor is what they call a mega nourishment project in the Netherlands. And so the Dutch coast is super vulnerable to coastal flooding and erosion. And so they regularly do beach nourishment projects to maintain the coastline and provide that important buffer between the North Sea and the developed areas along the coast. And so, you know, every 5 years or so, they are dredging up sediment and pumping it onshore and basically rebuilding their beaches to provide that protection. So in 2011, instead of doing that, they instead just built one gigantic peninsula of sand in one spot along the coast. And the idea is that, oh, let me actually, I have a picture of this. So let me share that. So there's a picture of it, of the Zonmotor. And the idea is that instead of nourishing the beach every 5 years or so, you can just make one huge sand peninsula and let the natural longshore drift kind of do the nourishment for you. So really creative project. And from what I've read, I actually have an aerial photo of this too. From what I've read, at least, this is working really well since it was installed in 2011. You know, all that sand is slowly making its way along the shore and replenishing the sand that gets eroded. So really neat project, and it just goes to show, right, that there's still a lot of room for innovation within civil engineering and coastal engineering. These projects, these beach nourishment projects, are not cheap. They're actually tremendously expensive and environmentally destructive projects to dredge all that sediment from the floor of the ocean and pump it on shore. And so if you could find, you know, a creative way to do it, or a cheaper way, or a less environmentally destructive way of doing that, that's really awesome. And that's something that the world really needs. And so there's, you know, people think of civil engineering as kind of an old profession where, you know, everything's been figured out already, but that's not true. There's still lots of room for innovation. And I think that's a really neat example of that. Let me see if there's any more questions coming in. Well, let's do another one of the Patreon questions. Actually, give me a minute. I need some coffee. This is another question that came in through Patreon. And Vincent says, Grady could have mentioned the effect of dams that permanently trap sediment from upland erosion from allowing the ocean and settling on adjacent beaches. And this is a really cool comment because it really illustrates a lot of interesting processes regarding, you know, sediment movement throughout the world. And yeah, the major point is that humans have had a dramatic impact on the sediment supply coming from the upland or continental areas by and making its way down to the ocean. And we've done that through damming up of major rivers. So when you create a dam and a reservoir, you slow down that flow, which allows the sediment that's inside to drop out of suspension. And one, you know, concept that's kind of hard to understand, but is really important here, is that the more sediment that's carried within a stream of flowing water, the less erosion that water can create, right? The water can only hold so much sediment. So if you starve a river of its natural sediment load, all of a sudden it becomes much more erosive. And this is something you see downstream of dams, is that, you know, once that sediment settles out, all of a sudden the water downstream is much more erosive, and much, you know, the stream and the beaches are much more prone to erosion once the water is starved of its natural sediment supply. Now, obviously, you know, we don't want the sediment in the reservoirs either, because it takes up valuable storage space. And so this is a major problem on both sides of the equation. And it's an unfortunate unintended consequence and a huge challenge, not only for reservoirs, because, you know, if you're sedimenting up your reservoir, you're losing storage space that can be used for water supply or hydropower or flood control. And basically you're reducing the value of your expensive infrastructure. And then downstream, you know, you've all of a sudden you've completely changed the regime of flow and sedimentation, which means the landscape is going to respond to that. And so again, just like the Zahn motor, this idea of reservoir sedimentation is a major challenge, and one that's completely ripe for, you know, for new ideas and solutions to the problem. Okay, I got a comment that says the servo is a little bit loud, so I'm going to turn that down. I hate to turn it all the way down. Maybe I'll just quiet it a little bit. Hopefully that's better. If not, post us in the chat and let us know. Let's see here. I think we've got one more comment from Patreon, and then maybe we'll switch over and answer some more questions from the chat. Actually, how does this look? We'll do that. Not that you guys need to see my big dumb face any bigger on your screen. So this comment comes from Dino Donut. Says, probably doesn't help that sand thieves literally steal beaches overnight to sell it on the black market to be used in construction. And you know, he's referring to this idea of illegal sand mining, which is a really interesting global phenomenon, mainly just because you wouldn't think of sand as something that people would want to steal. This comment is maybe a little bit dramatic, and I'll talk about why, but it is something that's happening in the world, and you know, it's worth mentioning for sure. So sand is a major constituent of concrete, which is obviously a really important construction material. And sand is also used for a variety of other purposes within construction. It's a really big resource, probably one of the most mined materials in the world. So you could see where it'd be valuable, especially in areas that don't have, you know, natural resources of sand, or areas a good supply of sand. But you know, beaches aren't jewelry stores. You can't just sneak in at night with 1,000 dump trucks and make off like a bandit. Mining is an industrial process, right? The margins are super low. You have to be extremely efficient with your fuel use and equipment and all that. Obviously, the economics change a little bit when you're not paying for access to the land or for the proper environmental permits. So I'm not saying that sand theft isn't a problem. It obviously is in many places that don't have access to sand supplies, but it's a little bit different type of problem than it sounds like at first. It's not like robbing a jewelry store. It's really kind of more of a certain country or area not having strong environmental regulations, or not enforcing those regulations strongly enough due to corruption or lack of resources or whatever. Stealing sand from beaches, it really isn't that common as far as I know. Beach sand isn't that good for concrete anyway, because it has a lot of salt in it, which, you know, reacts poorly with cement. And the other thing is, a lot of beaches are fairly exposed or even public areas, so it would be kind of hard to do something too nefarious without someone noticing. So, you know, sand theft is an interesting problem, but it may not be the exact type of problem that this comment suggests it is. So that's all the Patreon questions. So let me switch over to the chat, and we'll take some more questions from the chat. Okay, here's a good one. HP Logson says, not specifically related to this, but what are your thoughts on artificial sand that's essentially mechanically ground rock or gravel as concrete aggregate replacement? And this is something that is very common these days, especially, you know, if you have quarries nearby that are crushing rock anyway. A lot of times you can just sift and get artificial sand anyway. And a lot of times you have sand that that doesn't meet the specifications for the concrete mix design, and so you need to supplement or change the size of the grains in some way to get it to meet the specification. And in that case, yeah, you're using quote unquote artificial sand to supplement or change the properties of the sand that you do have. So this is a really common thing. I'm sure in some way it adds to the cost of the concrete, but in general, like this is something that that concrete manufacturers and quarries do every day. So nothing unusual about that. I'm looking for. Here's kind of a generalized question, but I'm happy for general questions. Sean says, I'm in high school and trying to decide if civil engineering is a field I want to go into. Do you have any advice on what the job opportunities are like? So first things first, assuming that you're in the United States, there's a resource called the Occupational Outlook Handbook. That's a one-stop shop for career information about, how quickly jobs are growing, where the opportunities are, what the salaries are, things like that. So definitely use that as a resource. For me personally, at least, infrastructure is something that we're all going to need. Our societies are becoming more and more urban, which means more and more infrastructure. A lot of structures that were built in the heyday of construction are kind of reaching the end of their design lives, and so we're seeing a lot of rehabilitation projects of dams and pump stations and pipelines and sewers and all kinds of stuff. And so at least from what I could see, the job prospects within civil engineering are really good, and we're always going to need people who can help design and rehabilitate infrastructure. So great question. Scrolling through questions. Here's a good one. How has civil engineering been affected by COVID? In the immediate term, there wasn't that big of a change, right? Construction was considered an essential activity in most places, and so construction sites kind of went on as if nothing was happening, for better or for worse. Most, at least from what I could see, most civil engineering firms were pretty set up for work from home anyway, and so it didn't cause that big of a disruption to the everyday, the day-to-day responsibilities of a civil engineer. But in the long term, I think we will see some changes, especially because cities are getting less tax, and so they're having to scale back on projects or delay projects, and so there probably will be an impact to civil engineering, just like there has been in lots of industries, but it might be a little bit different, or at least a little bit delayed. Let's see here. What's the most effective breakwater type, perpendicular or parallel to the coast, and why? What scenario would you use one or the other? So breakwater is parallel to the coast. That breakwater, quote unquote, is a structure that's by definition parallel to the coast, and it's a structure that breaks up wave energy before it makes it to the coast. And the structures that are perpendicular to the coast are called groins, and those are more intended to combat that longshore drift, where you're trying to keep sediment from making its way along the coastline. So say you have a piece of property, you don't want to lose all your sand, so maybe you install a groin to retain that sand. Now, if you're not careful, that can have unintended consequences, but if properly designed, the breakwaters and groins are essentially used for different purposes. There's a lot of comments coming in. I'm trying to keep up here. Here's another kind of general career question from Swamp Darner. Do you have any advice for engineering students who didn't have a chance to experience practical lessons due to COVID? Yeah, that's a tough thing. I feel really bad for the students who, didn't get the traditional education experience due to this pandemic. It's a tough thing, but there's a lot of ways to gain practical experience in engineering. There's lots of businesses still going on, so internships. It's always my #1 recommendation. If I could only tell students one piece of advice, it would be get internships, right? That practical experience working, for a city or for a consulting firm or any type of company that does engineering is going to way overshadow, anything else you do. And internships are so great because it gives you the opportunity to try something new and see if you like it, and it gives a company the opportunity to try a new person and see if they like that person and if they're a good fit. And there's a definite end, and so if things aren't working out, it's not forever. So I just think internships are so great, and honestly, I wish if I were back in college, that would be what I did every single summer. The other idea is, hey, go out to your garage and build something, right? That's how this channel got started, and it can be a lot of fun depending on what you're trying to do. Just get your hands dirty and try to put something together. Write a little bit of code on an Arduino, or there's just so many different ways to the barrier to entry to being a hobbyist now is so low. There's just so many different ways to get involved with engineering at a hands-on level. So definitely do that. Oh. Some of these comments are cracking me up. Here's a good one. Jonathan Griggs says, as a civil engineer, thank you for making the profession fun and practical to understand. That's part of why I started this channel too, is I didn't want people to think my career was boring. So I wanted to find a way to make it interesting to kids and to everyone. He says, have you considered doing a video on water and wastewater treatment? Yes, I have. I still haven't thought of a good demo that isn't disgusting. But water and wastewater treatment is largely a chemical engineering idea or process, and so that's something I don't have a lot of expertise in, and so it's something I would have to do a lot more research about and learn about. It's also something that's a lot harder to show on video, and so I try to focus videos around things that are highly visible and easy to demonstrate in a model. So if I think of a good demonstration for water and wastewater treatment, I definitely do want to do a video on that. And I am planning a video on sewers coming up soon. So the hydraulics of sanitary sewer lines. So that's somewhat related. Yay, wastewater, someone says. Is this video going to be recorded and uploaded? Yes, it is. At the end, I'll give the information about that. Let's see. A few questions. Someone said, I lost it, but it was something about what infrastructure needs the most improvement and would have the biggest impact. That's a tough question to answer, but I will say, with almost everything, with how much we use concrete, and hopefully you've heard this from other people as well, concrete is such an energy intensive substance to create, and we use so much of it within construction and engineering. So I really see that as, if we could find a way to make very hard, durable, strong substances take any shape like concrete can, for a very low cost like concrete is, then that would be, in my mind, the biggest way to change the world. And there's some really cool, you know, research into this and some really neat ideas that people have. So I hope that I hope we see some advances in concrete coming soon. Let's see. Devin Bork says, any advice for new channels? I haven't been that good at keeping up with all the new YouTubers coming up. You know, that it's tough to, when I'm out here in the garage, it's tough to spend time on YouTube. But one of my buddies, Ralph Crew, just started a channel called Isn't That Something? He's tackling a lot of really neat topics in a funny way. So if you haven't already, go check out that channel, Isn't That Something? Safi Halim says, can you suggest a good website to learn civil engineering? Not that I know of. You know, I do my best on my channel to kind of give you a flavor of civil engineering, but definitely don't go take the practical engineering or the professional engineering exam after watching my videos. In most cases, to become a credentialed engineer with a license to practice, you're going to have to go to 4 years of college and get a degree. It's unfortunate that that's the case, but you know, when you have a career that has such a big impact on public safety like civil engineering does, I think it's good in some ways that, you know, we are very rigorous about education and make sure that people really have the training that they need to do this job. Zach says that he's studying for the PE exam at the moment. If you're not familiar, civil engineers, at least in the United States, take an exam to get their professional license. You have to have 4 years of experience usually, and then you take this exam, which is 2 parts. Each part is 4 hours long. So it's a beast of a test, and it's a lot of studying. My advice is take practice tests. There's a lot of good ones out there, and to me, that was the best way to study, is just do practice problems and work through them. And if you get them wrong, you know, figure out why. And that gives you experience. One unique thing about the test is you can bring anything you want into the room with you. And so some people are carrying wagons of reference material to make sure that, you know, if a question comes up, they have the right book that has the answer. So you need to get practice, you know, finding things within those reference materials as well. Let's see if there's any more comments. Here's one comment. How about a video about how different soils react to water, swell, shrinkage, runoff, etc., and how they affect infrastructure? This is a cool idea. I have so many cool ideas on soils because, you know, it's such a mundane topic, except there's so many cool ways to make it interesting. So all you geotechnical engineers out there know what I'm talking about. There's a lot of cool demos, and the nice thing about soils is the effects scale really well. So, you know, if it's something that happens on a large scale, it's pretty easy to show on a small scale. I do have a video about shrink swell clays. It's something, when I moved here to San Antonio, my house is on this really, really expansive or really active clay. And so I started learning a lot more about that, and I was like, well, I'll make a video about it. And so I do have a video on that. There was a super chat I missed. What's your thought about erosion control systems like TrueGrid or other geocell systems? There's so many cool erosion control products out there. I haven't used that many of them in my projects. I used articulated concrete blocks, which are, you know, concrete blocks that kind of mesh together and lay along the surface of the soil to protect it from erosion against running water. But yeah, there's a lot of cool products out there, depending on the application, that can, you know, protect soils from erosion. Some of them look really nice. Some of them, you know, help with compressive loads like car tires and stuff like that to keep ruts from forming. So it's like I mentioned before, civil engineering is ripe for innovation, and there's still a lot of really cool products being developed that are interesting to keep your eye on. Let's see here. Well, we're about 4 minutes to the hour. I think with that I'm going to wrap up. So first of all, huge thanks to everyone joining the live stream, and I'll go full screen for this. I don't know how to make this question go away. It's gone too far. Oh, here we go. There we go. So yeah, as I mentioned, huge thanks to everyone for joining the live stream. This has been a lot of fun. I honestly had no idea what to expect, and this was a blast. So thank you all so much for joining. Someone asked, and the answer is yes, the recording of this live stream will be available in a playlist on the channel. So if you ever want to come back and watch it, or if you want to tell your friends about it for whatever reason, you know, just navigate to the live streams playlist on the channel and you'll be able to see it. I am going to make it unlisted so it doesn't show up in the regular video feed. If you have ideas or suggestions for the next live stream, you know, whether it's turn down that noisy servo or you know, this is in the middle of the night where I am, send me an email, right? This is an experiment and we're just trying something out. So I'm happy to listen to feedback and make improvements. And definitely, if you want to see more like this, like if people are enjoying this, I think it's a lot of fun, and it's a nice way to follow up the video and you know, show a few things that I didn't get to on the main video. So I think it's fun. And with that, we're going to sign off. I hope everyone has a great rest of your week, and I hope we see you back here soon. So we'll see you later.